Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be solving inequalities GMAT questions, and I already have questions on the concepts for inequalities, but in this particular video what I'll be doing is I'll actually be solving some hard questions, or you can say difficult questions on GMAT, which is going to be related to inequalities, right? So I actually got those questions from different sources. I got those questions from GMAT Club, from Manhattan. So what I'm going to be doing is I'm going to be solving those questions with you, and these are all 700 level questions. So these are all 700 plus level questions. So I'm pretty sure that we'll be learning a lot from this video. Okay. So let's go ahead and solve this, solve these questions, right? So here's what I recommend. I recommend you to go ahead and pause this video first. So if you pause this video and solve the question yourself and then see me solving it, and also I'll be solving these questions together with you, right? Okay, let's get started. So this is question number 1, and it looks like it's a data sufficiency question. It says that if 6xy, now whenever you see a data sufficiency question, the first thing that you need to do is kind of figure out what's there in the main question. So we have 6xy to be equal to x square y plus 9y, right? And the question is actually asking us the value of, the value of xy. Right, that's what the question is asking us. It's asking us the value of xy. So this is what the question is. Let's see. I think we should solve this first before we actually get to the answer options. So what I'm going to do is I'm going to, it looks natural to me to take this to the other side and make this a quadratic equation. So this is going to be 0 equal to x square y minus 6xy plus 9y, right? And then I have 0 equals to, now what I can do here is I can actually take y out of all these variables. So I had y here, and then I have x squared minus 6x plus 9, right? And remember, I cannot take this y down and destroy it. That is something that I cannot do, right? Unless I have some information about y. So what do I have here? 0 equals to y. So what is this? This is nothing but x minus 3 whole square, right? Because that's what it is. X squared plus x minus 3 whole square is x squared plus 3 square, which is 9, minus 2 3x, which is 6. So you can even split the middle factor and get to here. I actually got it pretty quickly because I'm used to seeing this. So this is what we have here. Now what do we get from here? What is the stem? So stem is that either y is 0 or x minus 3 is 0, right? So the only way this product to be 0 is either this is 0 or this whole thing is 0. So that means either y is 0 or x is 3. So that means, what is the value of xy? What are the two possibilities? Either xy is 0, which would be in the case when y is 0, or xy is equal to 3y. Right? So if I get the value of y, I'm pretty much golden here, right? Because if I get the value of y to be whatever I get the value of y, it's going to be 3y, or if I get x to be equal to 0, I'll get the answer. So let's see what the statement 1 tells us. Y minus x is equal to 3. From the looks of it, it looks insufficient, but we're not gonna stop there. We will actually prove it to be insufficient, right? So we have to make this satisfy. So either y is 0 or x is 3. Hey, why not take the same values, right? So you can take y to be 0. If y is 0, then x is going to be negative 3, right? In that case, xy is going to be 0, right? So that satisfies our question, or satisfies our statement. So I have a value. Or you can take x to be 3, which satisfies this. If x is 3, then y has to be 6, because 6 minus 3 has to be equal to 3. So xy will be equal to 18. So in that case, it satisfies the question, it satisfies the statement, and I have two different values for xy, which means this statement is insufficient, right? If this statement is insufficient, it's either answer option B, either answer option C, or either answer option E. Now we'll go to the second statement. So the second statement says x cube is actually less than 0. Okay, now if x cube is actually less than 0, what I can make out of it? Something that I can make out of it is that x is less than 0. Because if cube of a number is less than 0, that means the number has to be less than 0, right? So that is something which is a common practice. You can even start thinking about some numbers here. Negative 2 cube is less than 0, but 2 cube is actually greater than 0. So if you actually cube a positive number, you're going to get a positive number. But if you cube a negative number, you will get a negative number. So x is something which is less than 0, which means x cannot be 3, right? If x cannot be 3, that means y has to be 0. So if x cannot be 3, that actually implies y has to be 0. So that is something that you get from the question stem here. So if y has to be 0, that means xy will actually be equal to 0. So that means this statement is sufficient. Hence answer option B is my answer. Right? So just to reiterate the second statement, if x cube is less than 0, that means x is less than 0. If x is less than 0, that means x cannot be 3. If x cannot be 3, that means y has to be 0, because these are the two possibilities that are there. If y has to be 0, that means xy will have to be 0, because it doesn't matter what the value of x is. If y is 0, then xy is 0. Right? So let's move on to the next question. Okay, so let's move on to the next question. So the next question says that so we have y is an integer, right? And we have something known as the absolute value of x plus x that is actually equal to y. And the question is asking us the value of is y equal to 0 or not. Okay, so let's put everything in here. So y is an integer and y is equal to absolute x plus x. So the question is asking us is y equal to 0, right? So what value can y take? Now it depends on the value of x. Now if x is greater than 0, which means if x is positive, right, y can be, so if x is positive, absolute of x is actually equal to x, so that is x plus x, which is equal to 2x. If x is actually less than or equal to 0, right, so if y is actually going to be equal to, so if x is negative, then absolute of x is actually equal to negative of x if x is less than 0. Why is that? Because absolute of negative 2 is negative of negative 2. So that means here you have negative x plus x, which is actually equal to 0. So that means y can be equal to 2x or y can be equal to 0. That actually depends on the sign of the x. So let's see the question. So the question says statement. The statement 1 says x is less than 0. Now if x is less than 0, that means this is the case. That means y has to be equal to 0. If x is less than 0, then this thing will become negative, right? So this is sufficient. It's either answer option A or answer option D. Let's look at the second statement. It says y is less than 1. If y is less than 1 and y is an integer, that means y is less than or equal to 0. And when is y less than or equal to 0? That is only the case when x is less than or equal to 0, right? And in that case, the only value y can take is 0. Just to repeat the second statement again, if y is less than 1, again, what all values y can take? Y can take value of 2x where x is positive, or y can take the value of 0 where x is negative or less than equal to 0. So that means here y can either take positive values or it can take 0. And in this case it says y is less than 1, which means y has to be 0. Hence the answer option D is my answer, right? Because this statement is sufficient as well. So I hope you got it, guys. Let's move on to the next one. Okay, so what does the next question say? So the next question says is x square plus y square greater than 4a, right? So the question says, is x square plus y square greater than 4a? Right? Very ambiguous. A could be anything, x could be anything, y could be anything. Let's move on to statements straight away. So first one says x square plus y square plus 2xy is equal to 9a. You know, I've taken the liberty to expand this x plus y whole square, which is x square plus y square plus 2xy. So what is x square plus y square? X square plus y square is equal to 9a minus 2xy. Right? So it depends on xy, right? If xy is positive, then this value may become less than 4a, and if xy is negative, this value can become greater than 4a, right? So it could go either way. So that means this statement is insufficient. It's either answer option B, C, or E. Let's move on to the second statement. It says x minus y whole square is equal to a. So how do you open it? It says x square plus y square minus 2xy is equal to a. That means x square plus y square is actually equal to a plus 2xy. Again, this is the variable here, right? It can make this number greater than 4a, or it can make this number less than 4a. Again, depends on the value of x, depends on the value of y, and depends on the value of a, which means this is also insufficient. Hence B is gone. Let's combine both the statements, right? So we know x square plus y square is this, and we know x square plus y square is this from here, right? So that means these both numbers are going to be equal, right? So what I'm going to do is, just to make sure that I get x square plus y square on one side, I'm going to add both the equations. I'm going to add 1 and I'm going to add 2. So I'm going to get 2x square plus y square is actually equal to 9a plus a minus 2xy plus 2xy, right? It's minus 2xy plus 2xy. So this and this gets cancelled. So I get 2 times x square plus y square is equal to 10 times a, and I get x square plus y square to be equal to 5a. And the question is asked to me is x square plus y square greater than 4a? Now this is where the trick starts. Now if a is 1, then the answer to this question is a yes. Why? Because x square plus y square is actually equal to 5 when a is 1. Now is x square plus y square greater than 4? Yes. So it's a yes. But what if a is 0? If a is 0, then x square plus y square is actually equal to 5 times 0, right? Because you have a here. And is x square plus y square greater than 4 times 0? No, because it's actually equal to it. So that means you get a yes and you get a no even while combining the statements. Hence answer option C is also gone. Hence E is my answer. Had I was given the information that if a is equal to 0, then the answer would have been C. But I don't know anything about a. So a could be a negative number, a could be 0, or a could be a positive number. And if a is 0, then I get a no. If a is positive, then I get a yes. That means it's answer option E. Neither of the statement is sufficient. So I hope you got this, guys. I hope you understood it. Right? So I'll move on to the next statement. Next question. Okay, so let's look at this question. So this question says that are x and y both positive? So the question is asking, is x greater than 0 and y greater than 0? So first statement says that 2x minus 2y is equal to 1, which means x minus y is equal to half, which means x is equal to y plus half. This statement is insufficient because x could be 1, right, and y could be negative half. Sorry, x could be 1 and y could be half. That would make both positive. Or x could actually be a negative number like negative half, and y will have to be like negative 1, right? So in that case both are negative, right? Well, one thing that we know for sure, that x is greater than y, because x is equal to y plus half, right? That is something that we know for sure, right? So this statement is insufficient, right? Which is because it gives me both positive, it gives me both negative. Let's look at the second statement. It says x over y is greater than 1. Now this is a standard statement. What you can get from here is that if x is positive and y is positive, then x is greater than y. If x is negative and y is negative, right? So if x is negative and y is negative, y is greater than x. Why is that? Because whenever you see x over y greater than 1, it's either like 3 over 2 greater than 1 or negative 3 over negative 2 greater than 1. Either the top number is greater than the bottom number and they're both positive, or the top number is less than the bottom number and they're both negative. You can't have one and the other having different signs. They both have to have safe signs, and if both are positive, the numerator is greater than the denominator, and if both have negative signs, the numerator is actually less than the denominator. And this is insufficient for sure, because we don't know the signs, because x both could be positive and both could be negative. But if you combine both of them, you know x is greater than y from this statement, so that means this completely goes off the chart. So the only thing that is left is x is greater than y. Hence, combining both the statement is sufficient. So just to reiterate what I said here was, first statement tells you x is y plus half, which means x is greater than y. Second statement tells you that x over y is greater than 1, which means if they're both positive, then x is greater than y. If they're both negative, x is less than y. But statement 1 says x is greater than y, so this is gone. Hence, the only thing that is left is that they both are positive. Hence, C is my answer. Fine, so I hope everyone got this answer. Let's move on to the next one. So the next question, here it is. It asks us the value of y. What is y? Okay. First statement says 3 times absolute of x squared minus 4 plus 2 is y. So it depends on the value of x. If x is 0, this is something else. If x is 1, this is something else. So we don't know the value of y. So it's either answer option B, C, or D. Let's look at the second statement. 3 minus y absolute is equal to 11, which means 3 minus y could be 11, or 3 minus y could be negative 11. So that means y could actually be equal to negative 8, or y could actually be equal to 14. Two different values, insufficient. B gone. Now if you combine both the statements, what is y? Y is a positive number, because 3 times positive plus positive is positive, right? So that means we know for sure that y is a positive number. And the second statement gives us a negative number and a positive number. So that means the negative number cannot be the answer. So the only answer that we're left with is that y has to be equal to 14 for it to satisfy both the statements. Hence C is gone and D is the answer. Right? So I hope you got this, guys. I hope you understood. It was a very easy question. So moving on to the next one. Okay. So what does this question say? It says that if x and y are integers, so you know x is an integer, and y is an integer. So the question is asking us, is y greater than 0? Right? So the first statement says x plus 1 is greater than 0. You don't have any information on y. Right? The only thing that you know is x is greater than negative 1. Y could be anything. Insufficient. It's either B, C, or D. Let's move on to the second statement. It says x into y is greater than 0. The only information that you get is that either both of them carry positive signs or both of them carry negative signs, right? So in here y could be positive and y could be negative, so insufficient, right? Hence B is gone. Now if we combine the whole thing, what do you have? You have x is an integer, y is an integer, you have x being greater than -1. What's the next biggest integer greater than -1? So that means x belongs to 0, 1, 2, 3, all these numbers, right? And you do know that x into y is greater than 0, which means from here you know x cannot be 0, right? So if x cannot be 0, that means x has to be a positive number, right? So if x is a positive number, that means y has to be a positive number for x into y to be greater than 0. So hence answer option C is my answer. So reiterate again, x is an integer, but x is greater than -1. So that means x is either 0, 1, 2, 3, 4, all these numbers. And x into y is greater than 0. That means x cannot be 0. So 0 is gone. So x is all these numbers. And x into y is greater than 0. That means if x is positive, y has to be positive. Hence y is positive. Right, so I hope that was a good enough question. Let's move on to the next one. Okay, I like this one. So this question here says absolute of x plus 2 is equal to absolute of y plus 2. Now before even moving on, let's try to solve what does this say. There are 4 possibilities that can come out of it, right? So I'm gonna write all of them. One thing is that x plus 2 will be equal to y plus 2, right? In that case, x would be equal to y. So that's one possibility, right? Second is that negative of x plus 2 is equal to y plus 2. You know, negative of something could be positive of something. So because whenever you have two absolutes equal, there are 4 possibilities. Either both of them are positive, one is negative, the other is positive. Both of them are negative, or the other is negative and the other is positive. So if negative of x plus 2 is equal to y plus 2, what does that give me? That actually gives me that x plus y is equal to -4. That's what it gives me. What about the third one? It says x plus 2 could actually be equal to negative of y plus 2. What does that give me? That again gives me x plus y is equal to -4. What about the fourth one? Fourth one says negative of x plus 2 is equal to negative of y plus 2, and in this case here again x is equal to y, right? So these are the 4 possibilities that I have out of this particular statement, and that actually depends on the sign of x plus 2 and the sign of y plus 2. Basically it depends upon the sign of x and y. So the first statement tells me that x and y have different signs. So if x and y carry different signs, when is that possible? That is only possible when these both are true, because these are the only values where x and y carry different signs. Here x and y are positive, here x and y are negative. These are the only 2 and 3 are the only conditions where x and y carry different signs. So the only thing that you get from there is x plus y is -4, and the question is actually asking you the value of x plus y. So hence this statement is sufficient. It's either answer option A or answer option D. Let's look at the second statement. The second statement says x is greater than 2 and y is less than 2. Now from here you can infer that x is not equal to y. If x is not equal to y, then this cannot be true and this cannot be true. Because if x is equal to y, then both carry the same sign, but x is not equal to y. So the only possibilities that you get is x plus y is equal to -4. So that means this is also sufficient, hence D is my answer. So hope you got this, guys. I hope you understood this. Moving on to the next one. Okay, so things are getting trickier now. So what does this question say? It says A into B is not equal to 0. So A times B is not equal to 0. What does that imply? That implies neither A is 0 nor B is 0, right? So the question is asking us, is absolute of A divided by absolute of B equal to A over B? This is basically telling us is that does A and B carry the same sign or not? Because if A and B carry the same sign, then this would be true. Actually, it doesn't even matter. Absolute of A divided by absolute of B is actually equal to A over B. Yeah, that's what it is saying. This is going to be a positive number in any given case. Absolute of A is going to be positive, absolute of B is going to be positive. So basically the question is asking is A over B greater than 0? Right? That is what it is asking. So the only way it can be 0 is if A is positive and B is positive, and if A is negative and B is negative. So they both have to either have a positive sign or they both have to have a negative sign. That is the only time when this is going to be true. So that's just a fancy way of stating this, right? First statement says A times B absolute is equal to A times B. Again, this is similar way of saying this, because A into B absolute is going to be positive. So that means AB is greater than 0. And the only way AB can be greater than 0 is if they both carry the same signs. So if they both carry the same signs, and this is something that we want to know, if they both carry the same signs, hence this statement is sufficient. So it's either answer option A or answer option D. Let me reiterate what I did here. So this absolute of A of absolute of B was greater than 0. So the question is asking us, is A over B greater than 0? So the question is asking us is, does A and B have same signs? That's what it's asking us. And that's what statement 1 tells us. Statement 1 tells us that A into B is a positive number. The only way A and B can be positive is if they carry same signs, and we have already ruled out them being equal to 0. So this statement is sufficient. Let's look at the second statement. It says absolute of A divided by absolute of B is equal to absolute of A over B. Now here, A and B can have same signs, right? But they can also have different signs, right? So they can have same signs, they can have different signs. So this statement is insufficient, hence answer option A is my answer. So I hope you got the question here, what I was trying to explain, right? So that's what it is, right? And I think so I think the rest of the questions that I had I've already solved in other videos, so I don't need to solve them, right? Okay, so yeah, so thank you very much for watching this video, guys. Right, thank you very much. Just to let you know that I take a live course as well, where I teach GMAT Quant live, right? So you can actually get that course link on the on the website, just perfect-scores.com, and you can check out our Facebook page and also give us your valuable feedback on support@perfectscores.org, right? And for more videos, check out the website and check out the Facebook page for more updates. We got our Twitter page, Instagram page, all the pages are live, and yeah, so that's pretty much it, right? So thank you very much for watching this video, guys. I hope this was helpful in your GMAT journey, and I'll see you in the next one.